So today we're going to talk about something called domain and range. That is a way of describing what are the x values on the graph, what are the y values. So in a mathematical sentence, how can we tell what are the x values, what are the y values? Okay. Now, the word domain is referred to the x values. Right? If you start talking about the word domain, it's like the person is talking about the x values. If the word range is being talked about, that is being referred to the y values. Okay? And next year, you guys are going to talk about equations, and you're also going to talk about something called functions. We don't talk about that in grade 9, but when you have functions, which look just like equations, you have things called inputs and outputs. And the inputs are just your x values, your outputs are just y values. So just another way to interpret things. Okay, so more math vocabulary that gets put in. Okay? Now, I drew 5 graphs here of lines. And these lines look almost identical. They have the same y-intercept, they have the same slope, the same steepness. One of the main things that changes between these lines is how they start. Ooh, I don't like that color. How they start and how they finish. They have these different symbols. Okay? What you see is you see solid dots. Oh, that doesn't work. Come on. It's not wanting to switch colors. Sorry, you have solid dots there. Yeah, I don't know what's going on there. Okay, you have solid dots, you have hollow dots, and you also have arrows, right? So these are start and end points, and they have different meanings. Okay, let's talk about the arrow first. The arrow means, I think I need to restart this a second. Give me a second here. Close and restart. And make sure we are blocking. Yep. And here we go. Okay. So the arrow means that the line goes on forever in that direction. So whatever direction the arrow is pointing on, that means the line doesn't stop, but just keeps on going on forever in that direction. Goes on forever in that direction. Okay? And the two other symbols, the solid circle and the hollow circle, means the line stops here. Right? But the solid circle means that the line stops here or starts here, and we include this point. So it starts right here, and we include this point. All right. Point is included. And the hollow circle means that this point is not included. So it stops just shy of it. Goes almost right up to that number, but it stops just shy of it, or just starts just after it. Right? So point is not included. Right? So these things have subtle nuances in how we describe what are the x values, what are the y values for the graphs. Okay? Now, to describe them in math sentences, there are 2 different ways. There is something called interval notation and something called set notation. They're very similar, but the set notation is more of an abbreviated version of interval. And I'm going to start with that. So I'm going to go through here. We're going to do the set notation on these questions and sort of look at that kind of syntax, and we're going to look at the interval one afterwards. So unfortunately, when I was planning this, I didn't leave much space. So beneath all your graphs, kind of just divide it in half. These need space to write both types of syntaxes. What is set, what is interval. Okay, and we're going to start off with talking about what is set. Okay. Now, maybe up on the top here, we'll talk about set notation. Okay. Set notation is a combination of two numbers. Your starting point of your graph, your ending point of your graph. Okay? Start, end, and those aren't even the best words to use, right? If you're talking about x, we're looking for what's on the furthest left-hand side, right? If we're talking about domain, furthest left-hand side, and for the end, what's on the furthest right-hand side. For y, we're looking for what starts down here at the lowest end of y up to the highest. So we're always going from lowest to highest. Negative numbers to positive numbers, right? So maybe like lowest to highest, smallest to biggest, all right? Okay, so for this one, we're going to start off talking about the x. So x values are the horizontal values, right? So this is where our graph starts. This is where it ends. And so you don't need to shade this in like this, but all these values of x in here are the values of x on this graph, right? It starts over here, goes over here, so x exists. There's a spot on the line for x, every single spot along here, somewhere on this line. Okay, so we start off with the furthest left. What is the value of x here on the furthest left? Sorry? No. What is x right here? Close. -1, right? So we start off with the furthest left. We go, so this is for set notation. We go -1, comma, so the smallest is the most negative to the most biggest, most positive we can get. So what's the biggest value for x we have here? Sorry? How come? Oh, you're right. Is that positive, what did you say? 3. Yeah, +3. Okay, that is our values of which x spreads among. Now, we need to let the readers know, whoever's reading our math sentence, is this a closed dot, open dot, or an arrow? Right? So we use brackets to do that. Okay, for set notation, if you have a closed dot, which means point is included, we use square brackets. Okay, means that point is included. If you have a hollow point, which means, remember, the point is not included, we use round brackets. Okay. So when you're writing your notation down, be very deliberate. Make it extra curvy or extra square so I can tell that you're purposely using square brackets or you're purposely using round brackets. It's part of the communication. If I can't tell which one you're using, you won't get the credit for that. Okay, so now we look at, and we can mix and match these. These graphs can have solid dots and hollow dots. Looking at -1, this is the point. This is a solid point, so we're going to use a square bracket for that. So I put a square bracket down. Okay, and then going over here, that's a solid point as well. So at 3, we put another square bracket down. Okay, so that is our range of values for our domain. And we need to let people know that we're talking about domain. So we put a little D here and a little dot here. So that D is saying this is domain, and a reminder for us, these are x values, right? So, translating this into normal English, our x values for our graph are between -1 and 3. We include the point -1 and we also include the point 3. Right? That's all that information is in this tiny little statement. Right? So now we do the same thing for range. Right? So range, I'll use orange. Range are our y values. Right? Looking vertically. So looking in, these are y values, looking in this way. What are all of our y values? Right? We start the same way. We start with the smallest y value, the most negative y value. So we're starting off at the bottom of the graph. We work our way up from the bottom of the graph. We hit our point here. What is the y value for this point?
-2.
Yeah, -2. This is -2 here. So our y value here is -2. And go comma, and we're going to go to our maximum y value. So we go all the way up to the top, and our graph goes to this point here. What's our maximum y value here? 2. So it's comma 2. Okay. Now we talk about whether or not the points are included or not. So this bracket here refers to this point. At -2, we have a solid point. So we use a square bracket. At +2, we have another solid point, so we use another square bracket. Okay? And that's it. Right? The interval notation is a little bit trickier, but we're going to go through all these diagrams first, do the set notation, and I don't even think we'll have time to do the interval notation today. Right? And we'll save that for next day. So let's talk about this one. All right, so we have our set notation. It is the exact same line. So it has the exact same starting points and the exact same ending points. All we have to do is worry about what kind of bracket do we need to put here. So I'm going to just start off with writing domain down, range. It has the exact same starting points and end points. Right? So we write this down like so. Right? It starts at -1 here, goes all the way to +3. This one starts down at -2, goes all the way to +2. Now, it's a matter of which bracket do we use. So, starting at for domain, the furthest left point is this one here. So for domain here at -1, what kind of bracket do we use? Square bracket or round bracket? Square, all right? So I'm going to put a square bracket here. Then I go to the furthest right here, right? I'm sitting at 3, x value of 3. I got this hollow point here. What kind of bracket do I put here? Yeah, a rounded one. Right? So we put a rounded one that goes like this. Right? The left one is always opening bracket. The right one's always a closing bracket. Right? So we open and close our interval. Now we do something similar for the other one. Range. We're starting down here. The furthest left, -2. Square bracket or round bracket? Our y value is 1, 2. -2 here. Right? Square, yeah, thank you. So the green dot there is -2. We go to this dot here, and what are we sitting at? 2, and what, square bracket or round bracket? Round. Okay, pretty straightforward, right? All right. We set this up again. Domain -1, comma 3, range. This is the exact same line. All we're focused about is whether or not it's a square bracket or a round bracket. This time. Sorry? No. Round ones. We have a hollow dot for both of them. Right? So we don't even have to talk about it. There are going to be round ones. Round here, round here. There is no solid dot anywhere. Okay. Now, we get to this one here. So we're going to talk about set notation again. And I'm going to write down domain. I'm going to write down range. I'm going to write our values down. We are from -1 to 3, exact same line. Oops. No, it's not the exact same line. We have a different endpoint. What does the arrow mean again? It goes on forever, right? Infinity. So, the X, talk about domain. The furthest left we go is right here. What value are we at? Close? -1, right? Comma. Furthest right do we go? We are sitting at this arrow. The arrow means it goes on forever. What does going on forever mean? Sorry? Doesn't end, but mathematically, what's the number that goes on forever?
100.
Infinitely, right? So you put an infinity symbol in, which is a rotated 8, right? A sideways 8. Okay? All right. Now, if the line was pointing down, that would be -infinity, right? Because this way, for x, is going forever positive. It could go forever negative, then that would be a -infinity. All right. So now, we need to decide on the type of brackets. So -1 is sitting here. Square bracket or round bracket? Square. Okay. Infinity. Would that be a square bracket or round bracket? Square bracket means to include. Infinite means not to include. All right? Can we ever get to infinity? No. Right? So we can't do a square bracket, but you actually never achieve that number. So we have to do a round bracket for that one. So you never get there. Just keeps on going forever. It's not a finite thing. All right. Now let's talk about the range. So the range, we're working vertically. The left number is the lowest spot on the graph. What's the lowest number on this graph for y? Yep. The highest value in the graph is the second number here. Where does it go to? Infinite again. This line goes on forever up. It just keeps on going. Right? So it's infinite. All right. Okay. Starting at the lowest spot, round bracket or square bracket? Square. All right? And same situation as infinity. We never get there. So we'll do that. Okay. And I think we will stop right there. And we'll talk about interval notation next time.